Good morning. Everyone present here at 𝗗𝗄𝑠S and who have joined us today virtually through our YouTube live streaming. On behalf of the organizing committee, I extend a warm welcome to our director, distinguished scientist, research scholar, students, and all attendees. We are truly honored to have with us today Professor Anil Bhardwaj, Director PRL, and Dr. 𝗗𝗄𝗲𝗄, former Director 𝗗𝗄𝑠, and our superannuated few colleagues. We are gathered today for the Karunakaran Memorial Lecture in honor of Professor C. Karunakaran, the visionary founder member of 𝗗𝗄𝑠S. His pioneering vision and dedication continue to guide this institution in its journey of excellence in art science research. This memorial lecture is a moment of reflection and inspiration as we remember his contributions and draw strength from his legacy. To formally commence today's program, I now invite our Director, Sir, Professor 𝗗𝗲𝗄𝗲, our Chief Guest, Professor Anil Bhardwaj, and Dr. 𝗗𝗄𝗲𝗄, Sir, to kindly come up on the dais. Please, sir. Please welcome them. As a mark of respect and welcome, I request Dr. 𝗗𝗲𝗄𝗲 and Dr. Priyanka to present a flower bouquet to our guest, Professor Bhardwaj and Dr. 𝗗𝗄𝗲𝗄, sir. Thank you, 𝗗𝗲𝗄𝗲. Thank you, Priyanka. We shall now begin the program with an invocation. I would like to request Mr. Jitin for this invocation.
ഹൃദയരാഗതന്ത്രിമീട്ടി സ്നേഹഗീതമേകിയും കർമ്മഭൂമി തളിരിടുന്ന വർണ്ണമേകിയും നമ്മിൽ വാഴുമാദിനാമം ഇന്നു വാഴ്ത്തിടാം. പൂർണ്ണമീ ചരാചരങ്ങൾ ഗുരുവരങ്ങളാകണേ.
Thank you, Jitin. I now request our Director, Sir, our Chief Guest, and 𝗗𝗄𝗲𝗄, Sir, to kindly offer floral tribute to Professor Karunakaran in remembrance of his invaluable contribution to 𝗗𝗄𝑠S. To officially welcome all, I now invite our Director, Sir, to deliver the welcome address. Sir,
A very good morning to all of you. Professor Anil Bhardwaj, Director, Physical Research Laboratory and Chief Guest of today's function. Dr. 𝗗𝗄𝗲𝗄, former Director 𝗗𝗄𝑠. Scientists who are serving in 𝗗𝗄𝑠 and who served before. My dear colleagues, young researchers, staff members, several guests who have joined online. Welcome to this very special occasion to celebrate the legacy and contributions of Professor C. Karunakaran, the founder director of Center for Earth Science Studies. More than 4 decades ago, when the concept of Earth system science was still at infancy, a very distinguished geoscientist, Professor 𝗗𝗲𝗃 Karunakaran, had the imagination, dareness, and vision to conceive of 𝗧𝗏, where geoscience, ocean science, atmospheric science, bioscience, and environment science were brought together on a common platform with a mandate essentially to address the societal needs. The initial years were specifically devoted to the researchers in the Malabar coast and in the Sahyadri Western Ghat region. What started as a small institute with carefully selected, dedicated scientists drawn from diverse domains, pan-Indian level, has now emerged as one of the leading earth science organizations of the country. In fact, 𝗗𝗨𝗫 embodies in letter and spirit a miniature form of all activities of the Ministry of Earth Sciences. Dr. Baba will be formally introducing Dr. Karunakaran, but I thought, since being a geoscientist, I will also share few of my own thoughts a little bit. Professor Karunakaran was an alumnus of Banaras Hindu University, just like our chief guest, who also happens to be an alumnus of Banaras Hindu University. And Dr. Karunakaran went on to serve as Director General of Geological Survey of India, the premier most geoscience organization of the country, and served as head of the Department of Geology at Andhra University as well, Voltaire, where then he became, before he joined as founder director of 𝗧𝗏. He has several outstanding achievements, scientific achievements to his credit. Just to mention a couple of them, he led the first joint scientific expedition to the Great Nicobar Island in 1965, which has received worldwide attention. He pointed out that the Pygmalion Point and not the Kanyakumari, which was hitherto believed, was the southernmost part of India, which he demonstrated. He also organized expeditions to the glacier, 𝗂𝗲 glacier in Sikkim using geophysical methods, and was one of the first persons to measure the ice thickness using geophysical techniques. You all know India is the world's largest producer of barytes. It's in Kadapa Basin, Mangampet barytes. He is the man who explained the origin of Mangampet barytes. And the Indian expeditions to Antarctica was also over his blind child, which he submitted to the then Prime Minister at that time. So as a tribute to his immense scientific contributions, annual Professor Karunakaran Endowment Lecture was first initiated by 𝗧𝗏 and of course later on by 𝗗𝗨𝗫 in year 2000. The inaugural lecture was delivered by none other than Dr. 𝗂𝗲𝗄𝗏. And so far, we had 13 such endowment lectures delivered by some of the esteemed scientists of our country. I mean, they're all household names. Professor Anil Kakotker, Professor M.S. Swaminathan, Professor Padmanabhan, Vinod Gaur, Professor 𝗓𝗏𝗄𝗏, Dr. Sailesh Nayak, and we have Professor Anil Bhardwaj, amongst many others who gave before. After there was a hiatus in the lectures after 2016 for some unknown reasons, and this lecture series has been revived after I took over, and it has been renamed as Karunakaran Memorial Lectures instead of Endowment Lectures. And the purpose of having these lectures is not only to cherish the contributions of Professor Karunakaran, but also for the sake of scientific posterity, we need to take such things ahead. So Professor Bhardwaj, whom I will be formally introducing, is the director of PRL, and his association with Tiruvanaanthapuram goes back to last century. He is a resident of Tiruvanaanthapuram. He has a house here because he started his research career at Vikram Sarabhai Center, SPL Lab. And he collaborated with some of our scientists, and he also served here as a governing body member of our 𝗗𝗨𝗫, so he is very familiar with our institute. So I also would like to share a few things about 𝗗𝗨𝗫 to Professor Bhardwaj, because he is not, he may not be aware of the developments in last 5-6 years. So 𝗗𝗨𝗫 today is actually expanding its activity. We are working right from Himalayas to southern granite terrain, in literally speaking Kashmir to Kanyakumari and Andamans. We are also working on Antarctica, and also we are trying to enter into the North Pole, Arctic regions. And the second thing is 90% of our scientists are in the age group of 40. It's a very young institute if you compare with many other institutes of CSIR or other DBT or DST institutes. And lot of academic achievements have been made by our scientists, including Young Scientist Award. Lot of young project grants have been received by them. In science and technology, I can say very proudly in geochronology, in situ geochronological measurements, we are actually on par with any other lab in the country on with them, like laser ablation, ICP-MS and all these things. We are doing extremely well as evidenced by our publication records. We are also leading in critical zone research, in coastal zone management, and in atmospheric science. Our group may be small, but we are very vibrant. We are making a lot of impactful studies on lightning, atmospheric cloud microphysics, and we have set up important observatories, and where our observatory data is very invaluable in a lot of modeling studies, river pollution, and we are entering into microplastic domains. And recently ISRO has invited us to be a part of the Chandrayaan next mission 3, and Dr. Bhardwaj was also there when our scientists went to ISRO and we presented. And in societal aspects, right from CESS days, we have been always with the society. We are taking care of coastal management and hidden subsurface structures. We are revealing a lot of things, and we are also playing an important role in forensic sciences. Police State Department, especially Kerala Police Department, approaches us to track some hidden things, some dead body boxes and so forth. So our scientists are involved using GPR techniques and all these things. And we have also involved in mapping the subsurface tunnels in Rashtrapati Bhavan at the behest of our secretary, Dr. Ravichandran. We did that job. And another important aspect is there is an extensive collaboration between our scientists. There is no bureaucratic level. Each of them collaborate with others very happily and readily. That's a plus point which I noticed. And we have so many sophisticated analytical facilities which are very functional. They are open to everyone. And we insist the scientists from outside institutions, they should be here. They should work on them and generate their own data. So we are working in these lines. And recently we have filled our strengths. Now 4 new scientists were recruited after I joined. We are expanding our activities into new frontiers like planetary geosciences, critical minerals, which are all the need of the country. We are going to expand. And also we want to come up in a big way in AI and ML in all applications. So the year 2028 is going to be a landmark year because ESSO-NCESS would be celebrating its golden jubilee year. And so we are planning in that direction. The building which was lying like that for a few years before I joined is getting renovated. I am assured that it will be ready with the 1st October. You can see progress. So that is one major landmark we are going to achieve. And we are also planning to come up with girls hostel, because that is essential, because to have good students we need to provide accommodation as well, and some residential accommodation, especially for women. We are trying to target as the first phase towards the golden jubilee. And all the project staff positions right now in institute are filled. I am told by Dr. Thompson that first time since last half a decade, all the project staff positions are in place, and we have some of the best brains and minds from all over India. All IITs, ESR labs, and all state and central universities have been recruited absolutely on merit basis. So I once again welcome all of you on this August occasion, and I should also place my grateful thanks to my secretary, Dr. Ravichandran, who is the driving force, who provides a lot of support, inspiration and advice to me in each and every endeavor. Without his support, nothing I would have taken it forward. So thanks to each of you, and I wish that we have a very privileged speaker, and everybody will be benefited by his presence. Thank you very much.
Thank you, sir, for portraying NCESS activity in such a way. Thank you once again. To further reflect on the life and legacy of Professor C. Karunakaran, I now invite our former director, 𝗓𝗏𝗏 sir, to share his thoughts and memories.
My dear Professor 𝗗𝗏𝗃, Dr. Anil Bhardwaj, Suresh Babu, my old colleague 𝗧𝗶𝗺𝗲, and my good friends, youngsters. My old colleague has come, 𝗓𝗏𝗃𝗄𝗧, right? Okay, so on my behalf, I welcome you again to this great function which was initiated when I was there on the helm of affairs in 2000. And this picture of a portrait of Professor Karunakaran was made during that time. So a lot of things were told about Professor Karunakaran. He was like a father figure for me. He was born in 1917. My father was also born in 1917. So always I gave him that respect. And he also nurtured me as a very young son. So Professor Karunakaran is known as a geologist for most of the people because of his long association with the Geological Society of Geological Survey of India. But there are so many hidden passions for Professor Karunakaran. In addition to geology, he always nurtured the field of environmental sciences, and he had a passion for marine geology. I think his first appointment was in Andhra University as a lecturer in the geology department. At that time, I think in the oceanography, there was a department of meteorology and oceanography. They invited, Andhra University was famous at that time. They invited Eugen Lafont of Scripps Institute of Oceanography, USA, and to initiate ocean studies. So Professor Karunakaran was there at that time, and they did, along with Professor Eugen Lafont, they did a lot of surveys along the East Coast and named and found out several submarine canyons. They were not known at that time. So this, one of the submarine canyon was known in the name of Lafont, a Lafont Canyon. Yeah. So that was his passion for, at that time he developed that passion for marine geology. That led him to so many things. For example, when he was in the Geological Survey of India, he was instrumental in initiating a lot of studies on marine geology. Otherwise, it was all land geology, which was handled by GSI. He encouraged people like Dr. Siddiq, H.N. Siddiq, Dr. Malik. There was one more person, I forgot his name. So these three people were pioneers in initiating marine geology in Geological Survey of India, and Professor Karunakaran was behind that. And that passion he retained, and he always tried to explore the ocean depth, ocean bottom. He became a scuba diver. He himself became a scuba diver. And I remember when he was here during his free times, when he was in SES, during his free times he used to go to Kovalam with some naval friends and go for scuba diving. So that was his passion. And that is why he encouraged marine geology here. That is one reason. And then what happened, the planning board, Kerala Planning Board invited him after his retirement to see what is happening to the coast and how to control this severe coastal erosion Kerala is facing. He looked at it and then, I'm just giving you some background. He looked at it and he found that the basic reason is lack of science. The geology of Kerala was not well known because geology plays a very important role. The geomorphology, geology plays an important role in this coastal erosion process. Similarly, the ocean bottom, the sediment movement and all those things. So he thought that it is not just an engineering problem, it is a science problem. So then he slowly, sitting in the planning board office in Pattam, he slowly started planning for an institute, and this came, the government was very supportive, and this came the Center for Earth Science Studies, not a Center for Coastal Erosion Studies, not a Center for Geological Studies, it's Center for Earth Science Studies, because he knew that it is the combination of all these sciences creating problems. And coastal, that was only an initiative, that is an igniting thing for him to, in his journey towards the encouraging earth science research. You know, you may not be knowing, he was a towering personality with his spectacled lens. He moves around like this and then with very few words, but his eyes will tell you what he wants. So like that he moves around not this campus, of course at that time it was a rented office in 𝗓𝗲𝗃𝗃, 2 or 3 buildings. I joined at that time. And then there was a 3-storied building in Shastamangalam, a rented building. From there, this building was made. And he, you know, people are really hesitating to go and talk to him because he is so. Because I remember one occasion, in 1978 I joined, and 79 he recruited me. I will tell you the background. So in 79, I got a call from IIT Delhi to join there as an assistant professor. So they were starting an ocean engineering center. So without my application, they located my background and then invited me. I gave this letter to Professor Karunakaran when we were in the Jawaharnagar. You know what he did? He gave me a white paper. He threw a white paper to me and said that you write your resignation and go wherever you want. This is what he did with me, I remember. So I said, sir, I am not going anywhere. So I will be here. You know, because of his passion for marine geology, he had an eye on NIO at that time. NIO was shining star at that time. He wanted to have some top people. Dr. 𝗗𝗁𝗃𝗃 was there at that time as head of the geology division, marine geology division. And he wanted to have some more people. At that time, I was there in NIO. I just joined. I returned after my PhD, and I was there. He met 𝗗𝗁𝗃𝗃 and he offered him a deputy director post, and still it was pending. And then he met me also there. And of course, at that time, he did not tell me anything. After coming here, that was in 78. After coming here, he called me and he said that he sent me a letter saying that, why don't you come to Trivandrum and meet me? Like that I did. Similarly, afterwards, he invited or recruited some people from NIO. Terry Machado, my colleague, he joined in 79, right? 79. And my first paper was published with Terry Machado. And then another one, Dr. 𝗓𝗃𝗃𝗃 was also. These 3 people he got from NIO. And like that he started the marine studies. So that was the type of thing. And his interest was not to make a Kerala institute. His interest was to make not even a national institute. His interest was to make it a global institute, because earth science institutes were not there at that time. So this new, as Professor 𝗗𝗁𝗃𝗃 told, the concept of putting all looking at the earth as a planet, not as a landform or a water form or something like that, or atmosphere. Putting all this together, because all these things together make our planet. So he had that concept of planetary approach in framing this institute, and he wanted the top brains from all over the world to come and work here. So he went to US. He had a very close association with the US Geological Survey. And he had a lot of friends there. And similarly, in the Scripps Institute of Oceanography, Woodsville Oceanographic Institute, like that. He toured around that, and he invited a lot of people from there. And of course, nobody joined as scientists at that time, but he brought a lot of delegations from there. You understand? So even Professor Lafond was an old man. At that time, he was alive, and he brought him here. And of course, as a young scientist, I also joined him, joined Professor Karunakaran in taking these delegations, geological survey of USA, delegations to the then Chief Minister, Mr. Nayanar, I remember. So this was his background. So, and he went to several other countries, like France. When he was here as director, he went to France, and he wanted to bring some young people from there, Indian scientists who are working there, to bring them here. He did not succeed, but he succeeded in one thing. That what is that? One great marine geology researcher was there, one Frenchman. He had a good association with him, and he brought him here. He brought him here to go to the depths of the oceans. But unfortunately, that also did not pick up very, very nicely at that time. So like that, Professor Karunakaran wanted to make it a global institute. That was the vision. That was the vision. So, of course, we are slowly achieving that, and in present days, I am seeing that there are a lot of things happening, and collaborations with other institutions. That is one thing which he wanted, and that is why he was the first chairman of the 𝗗𝗲𝗂𝗗 Institute of Himalayan Geology, and there, of course, in initiating that activity there, he gave a lot of support, and Professor 𝗵𝗂𝗵𝗂𝗵𝗂𝗵𝗂𝗵𝗂 was the secretary of DST at that time, and under him, they worked together to bring that institution up, along with the 𝗧𝗶𝗺. So like that, these are some of the, and as an environmentalist, I'll just finally say that as an environmentalist, he never kept quiet. I remember he took all very few scientists here at that time, took all of us for a demonstration against the Silent Valley movement. You remember? Yes, Silent Valley, because some dam was coming up in Silent Valley, and so there was a lot of protest against it, because it was a virgin forest. So we, along the streets, we led a demonstration under his leadership. Because so many other NGOs were there. So like that, so that environmental thinking was very strong in him. And in addition to in geology, of course, I forgot that during his time, he established a memorial for, what is his name? The first Englishman who researched, Buchanan researched the Kerala laterites. So he established a memorial for him in Nilambur. Is it in Nilambur? Angadipuram. So that was established at that time, and is that you have it, yeah. So these are type of things, he was a very broad thinker, and like that. So I think I can narrate so many stories, but I am going to, because we have our learned speaker here, so let him give us some new thoughts. As an engineer, at the end of his term here, of course, it was not very fortunate. It was quite an unfortunate ending of his tenure here. I don't want to go into that. And he did not keep quiet. He went to what is called Ooty and Kodaikanal, and he organized the school students to beautify Kodaikanal with tree planting and environmental protection and all those things. Spent some few years there. And like that, he was a totally different person. We could not, during our times, we cannot think that such a person can get involved in so many things, and very broad. And he wanted the CESS to come up like that, with incorporating the atmospheric, marine, and the geological side together, and go for some new programs, which even DST at that time was not envisaging. So he proposed that. But then afterwards, he had to go suddenly after 4 years. So certain things happened afterwards. So that is all history, and it is continuing here. So I bow my head the memory of Professor Karunakaran, my fatherly guide, and I hope you will all try to remember this and bring this institution to the top level as he envisaged at that time. Thank you very much.
Thank you, sir, for your heartfelt words of remembrance. I now again invite our director, sir, to introduce our today's chief guest.
It's my great pleasure to introduce Professor Anil Bhardwaj, the chief guest of today's function. Professor Bhardwaj received his MSc from Lucknow University and PhD from IIT Banaras Hindu University in 1992. He then joined ISRO in 1993 as a scientist at the Space Physics Laboratory of the 𝗗𝗃𝗲 Space Center in Trivandrum. He subsequently became the head of the newly formed Planetary Science Group of SPL in 2007, and finally became the director of SPL, and where he served from 2014 to February 2017. And since 2017, he has been the director of the Physical Research Laboratory Ahmedabad, created by none other than Dr. 𝗗𝗃𝗲 himself. He has worked at NASA Marshall Space Flight Center in US for about 2 years as National Academy of Science Senior Research Associate during 2004 to 2005. Professor Bhardwaj initiated the research in planetary science at SPL and contributed immensely to the development of planetary science program in ISRO and planning of planetary missions of India. He was the principal investigator of SARA experiment on the first Indian lunar mission we all are aware of, Chandrayaan-1, which has revolutionized our understanding of the interaction of the solar wind with the moon through several new findings. He was a PI of Menka experiment on the Indian Mars orbiter mission. He and his team have led several experiments on Chandrayaan-2 orbiter, Chandrayaan-3 lander and rover missions, as well as the solar mission Aditya L1, about which we had a talk not in this week earlier by Professor Banerjee. He has been an observer on Chandra and Newton X-ray observatories, Hubble Space Telescope and Giant Meter Wave Radio Telescope. So his primary research field is planetary and space sciences and solar system exploration. He has made outstanding contributions in the field of solar system X-ray astronomy, including discovery of X-rays from the rings of Saturn and X-ray flares from Jupiter and Saturn, and theoretical modeling of aurora, air glow emissions and photochemistry in planetary upper atmosphere and ionosphere and on comets. His research findings have led to several press releases by NASA and European Space Agency and ISRO, of course, and story of the week and cover pages of American, European and our national journal as highlights. Professor Bhardwaj has published more than 220 peer-reviewed research papers, and today morning I checked his H-index is 42 with more than 6,500 citations and several publications. Any scientist, I always believe, should be evaluated also by the type of students he or she has created, and there he had led successfully several students for their PhDs, MTech, MPhil, MSc, BTech, and one of his students also served as a postdoc here, not very recently she left, Dr. 𝗗𝗃𝗲 Mukundan. She was a postdoc here at our institute. And he has been editorial board member of several national journals, member of governing council of number of allied research institutes, which I don't want to name, but he served as GB member of our 𝗗𝑁CESS few years ago, and chairman and member of several national, international science committees. He is internationally also very well recognized. He is the president of Asia-Oceania Geoscience Society of Planetary Sciences. He was the vice chair of 𝗂𝗲𝗃 Commission during 2012-20. He is also the founding president of Indian Planetary Science Association and board of trustee of International Academy of Astronautics since 2023. He has organized more than 65 scientific sessions at international conferences. Today morning, Dr. 𝗗𝗃𝗲𝗄 at VSSC was telling Professor Bhardwaj used to organize so many events very frequently, and they really miss him nowadays. And many national events. And in recent years, he delivered more than 50 plenary talks at conferences and all. Professor Bhardwaj is an elected fellow of all the 3 National Science Academies India and of many other academy societies, and has received immense recognition at both an international level, including 2 of the most coveted awards in earth sciences, 𝗗𝗵𝗃 Bhatnagar Prize in 2007 and Infosys Prize in 2016. He is also a recipient of 𝗗𝗵𝗃𝗄𝗃 Memorial International Award, Decennial Award of Indian Geophysical Union, J.C. Bose National Fellowship, Professor M.G.K. Menon Lecture Award of NASI, AOGS Fellowship, and INSA Distinguished Lecturer Fellowship last year, I remember, he got that. I mean, these are few things which I thought I should mention. In 2024, he received the coveted Vikram Sarabhai Medal of 𝗂𝗲𝗃 and International Academy of Astronautics Basic Science Section Award. He also received Distinguished Alumni Award of IIT BHU in 2015 and Lucknow University as well. And Professor Bhardwaj is revered by ISRO in 2017 with the highest in-service award, the Outstanding Achievement Award. Professor Bhardwaj also actively engages in public outreach activities and has delivered more than 100 lectures and interacted with more than 1 lakh school students, teachers, and initiated new programs for underprivileged and girl students in rural areas, which has impacted nearly 30,000 students. If you want more, you can visit PRL website to see how vibrant he has turned that organization into after he has taken over in outreach activities. A chapter, A Rocket to Poke Martians, on the life and work of Professor Bhardwaj is published in children's book, They Made What, in 2021. And he is listed in the book 100 Great IITians Dedicated to Service of the Nation. I think we are privileged to have such a stalwart scientist among us, and we look forward to his lecture, and we again thank him for taking his time to be amidst all of us. Thank you, Professor Bhardwaj. Can you please take this chair?
Not on. And can you put on the laptop? Okay, so good morning everyone, and thanks Professor 𝗗𝗵𝗃𝗲 for a very long introduction, detailing too much of it. And also thanks for bringing me over here. It's always a pleasure to be at 𝗗𝗫𝗫𝗫s, and it's a greater pleasure because I am here for the Karunakaran Lecture, Memorial Lecture, 14th Memorial Lecture. And we have already heard from Professor Baba about the contribution of Professor Karunakaran. And it's also a remembrance that how good institutes are built based on the legacy of scientists who have worked hard in their own field. So I thank all the staff of 𝗗𝗫𝗫𝗫s and the faculties, students, my own colleagues from SPL, VSSC present over here, and all of you for this lecture, which is the 14th in the series. I took the topic as Planetary Exploration Mission of India, and I would like to just run through what has happened in the past, what is happening currently, and what we are planning to do in the future. And this is more like a popular, because I know there is a diverse viewership, not only in the hall but also online. And therefore, I thought I will not put any equations in this talk. It will be full of pictures and probably a few of the movies, just to highlight how we have taken forward the science into the global scene of understanding of various planetary bodies in the solar system. You are seeing over here pictures in the bottom of the launch vehicle, which is essentially required to take the spacecraft into space. And of course, the many spacecraft, which is a part of exploration, which is done by India. And as you know that I come from PRL, which is an institute established by Dr. 𝗂𝗲𝗺 in the year 1947, the year we became independent. And all the exploration program started under the leadership of Dr. 𝗂𝗲𝗺, whether it's the rocketry program, the satellite program, the ballooning program, the application program. And that is why PRL is called as the cradle of space science or space research in India, because everything started from PRL. And the 𝗗𝗲𝗺, which is a rocket launching station, that time established by Dr. 𝗂𝗲𝗺 and Dr. Bhava. And the program in the country actually started becoming wider and wider. And Professor Kalam, who was working with him at PRL, was actually sent here in 𝗗𝗲𝗺 to start the rocketry program. You can see also here Madhavan Nair, who later on became the chairman ISRO, Secretary Department of Space. And the first rocket launch which took place from this shore of 𝗗𝗲𝗺, just maybe a few kilometers from here, actually carried experiments which were developed in PRL. So PRL was known for developing instruments which are flying on various missions. Now talking about the PRL itself a little bit more, and we have currently 4 campuses. We have the main campus in Ahmedabad, which you see over here in the top. This is the part of the building which came up in late 50s, or early 50s, I should say. And it was inaugurated by then Prime Minister Pandit Nehru. We have another building in 𝗗𝗏𝗃, or a campus in 𝗗𝗏𝗃, which is about 5 kilometers from the main campus. And then we have a campus in Udaipur, which is called Udaipur Solar Observatory, which is in the middle of the lake Fateh Sagar. And there is a campus nearby, or an office, I should say. And then we have a campus in Mount Abu, which is basically an observatory, and we have recently added this 2.5-meter telescope building in about 2 years back. And this is a 1.2-meter telescope, which is there for last 4 decades. If you talk about what kind of research is carried out, as 𝗗𝗲𝗺 was talking about what's happening in 𝗏𝑠𝑠, so I thought I will tell you about that. The research gamut of activities encompasses astronomy, astrophysics, solar physics, planetary science, space temperature science, geoscience, theoretical physics, atomic molecular optical physics, and of course a very strong foundation of students and doctoral programs and postdoctoral programs. So if you essentially combine all these activities and say what PRL is doing, PRL is actually looking from the core of the earth to close to all end of universe. So that is a broad domain of research in which PRL is working. And before I really embark on my topic, I should also acknowledge the great contributions which comes when you talk about any mission, because it is not one single person or a group of person who do this. There's a large pool of scientists and engineers who actually take part in this kind of missions, right from the rocket launchings to satellite buildings to payload development to ground support to the people who actually look at the data, analyze, and then do the publications. So if you talk about how many people get involved in single mission, it will be in thousands actually. And therefore, I should acknowledge all of them who actually contribute, because success of the mission lies in each and every part of it. Now let me talk about very briefly about Planetary Exploration Program. I think this mic is working. Can you hear me? Yeah, perfect. I think I can put it off. it's okay. I think. No. Not audible. Is it better now? No? ये ज़्यादा अच्छा है. This is not working. Only this one is working. You want me to wear this headgear, eh? कैसे जाएगा? ऐसे जाएगा. Hello? Is it better now? But I am feeling uncomfortable. Okay. Is better now? Briefing on all these three missions. So I will talk to you about the Mars Orbiter mission, which is a successful mission. Launched in October of 22nd after carrying 11 experiments on board, and 3 of them were actually going for the first time in any planetary exploration mission. If you are finding any difficulty in my voice, please tell me. I believe it's okay or better than before. Okay. And if you look at this whole space, should be pretty big. These are the experiments we call as payload, pay and load. Okay. And I was directly involved with an instrument called 𝗓𝗲. But you see a gray box over here, which was also had an instrument called 𝗗𝗲 SPL. And this gray box was actually released 100 km circular polar orbit. And this made MIP, the Moon Impact Probe, the first man-made object from India landing onto the lunar surface. And this happened on 4th November 2008, which is also the Children's Day. The 𝗗𝗲 instrument provided us a lot about the distribution of various gases present in the exosphere of the moon. We don't have we have an exosphere, that means there is no collisions happening between molecules. I think voice is okay, or it is modulating. I am seeing some vibrations to me, that's why I am able to sense. Modulating, right? इसी को use करते हैं. Okay, so this is better and more comfortable for me also. So this is the first observation of its kind for argon, which is AMU40 and H2. And since it was an MIP which started from very close to the equator and falling down towards the South Pole, we have a distribution of altitude versus latitude, and this is how the gases were measured for the first time. We also have observations of neon, which is AMU20. And if you put the scale height concept into this kind of observations, you can actually make a 2D plot, latitude versus altitude, which was done. What has Chandrayaan-1 brought to us? We were all thinking moon is bone dry, there is no water on the moon, but Chandrayaan-1 mission has discovered water on the moon. And now we know that water exists on the surface, beneath the surface, and above the surface. We also now know that moon is not geologically dead. It is both volcanically and tectonically active. We also know now that the solar wind, which is plasma coming from the sun, is not completely absorbed, and I will talk to you a little bit about that. And also, we discovered many locations where human habitat can actually exist, including the buried lava flows. There are more than 250 scientific publications which has come out, several of them coming on the cover pages of various journals like Science or GRL. How does the surface of the moon looks like? This is how it is. एक lights front में off कर सकते हैं? Can you put out the lights in the front so that you can see a better view? Off कर दीजिए, off. Front lights off कर दीजिए सब ये वाला. All lights, if you put it off, you will see it better. Movie theater बना सकते हैं. You put off the lights. You will see it better because Yeah, I hope it is much better, right? So this is how the surface of the moon looks like. All these white patches which are seeing there are craters of all possible dimensions, from meters to kilometers to hundreds to thousands of kilometers, and big craters are actually called as basins. So moon has the biggest basin, which is called 𝗓𝗶𝗺𝗲 Basin, which is several thousand kilometers in diameter, and it is almost like 8 kilometers deep, which is the biggest basin of the solar system. The 𝗬𝗲 experiment, where I was directly involved, had two sensors, SWIM, which is measuring the solar wind charge particle, which is coming from the sun, and 𝗓𝗗, which was basically flown for the first time for exploring the moon to look at energetic neutral atoms. This is a new technology which was being tested on this mission. And this has given us a lot of new information. First, let me brief you a little bit about how the moon goes around the sun. As you know that Earth has magnetic field, and because of which we have a magnetosphere and magnetotail. And this is 𝗏. And this is the orbit of the moon as it goes around the sun. It takes about 28 days to go around. So you can say about 7 to 8 days it is inside the Earth's magnetosphere or magnetotail. But other than that, 2/3 of its orbit, the moon is in the pure solar wind. So that means moon is actually incurring two different kind of plasma. And this plasma which is coming from the sun, which is called solar wind, a wind coming from the sun, largely consisting of almost like 95% protons, a few percent of Wi and helium, and all other heavier elements, moving with a velocity of 400 km per second, that is supersonic, and carrying its magnetic field, interacts, and we knew that we get a very simple picture like this. The whole solar wind gets absorbed, there is no atmosphere, no magnetic field, and we get a cavity or a wake in the night side. This whole picture has not changed into this complex picture which has come out from this instrument called 𝗬𝗲 on the Chandrayaan-1, essentially telling that not all is absorbed on the day side, about 1/5 of the impacting solar wind, or 20%, is backscattered as neutral hydrogen. This was almost a discovery. In addition, we also knew now that mini magnetosphere get formed on the moon just because of the presence of magnetic anomalies of few hundreds of nanoteslas on the surface. You get a mini magnetosphere which get formed, which was discovered by the 𝗬𝗲 instrument. So this 𝗓𝗗 observations, which in fact told that you can use hydrogen as a means to study the moon, became the ESA press release that time. And it says that hydrogen offers a new way to study the moon. Also, we now know that this solar wind actually reaches the night side, is not a wake, and it impacts the night side because we have ENA production right from the surface. And this was also a revealing thing that nobody was expecting this charged particles from the sun to really bend down and hit the night side of the moon. So a lot of new science has come out from this, and each arrow which you see over here is actually a publication. We also used a very innovative way to understand whether there is a plasma on the moon. So we used this 32-meter antenna of Indian Deep Space Network, very close to Bangalore in Bailalu, to log the oscillator on the spacecraft and to look at the two-way communication to find out the plasma properties very close to the surface of the moon. And we found that densities of about few hundred particles per cc can be there around the moon. And I will bring this topic back when I talk about the Chandrayaan-3 mission. Mars orbiter mission, very celebrated mission. We had the launch in November of 2013. And after 10 months of travel, we reached Mars. And that made India the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. No other country has actually achieved that. This mission carried 5 experiments on board, and I was directly involved with an instrument called MENCA, or Mars Exospheric Neutral Composition Analyzer. This MENCA is not the MENCA of Rishi Vishwamitra, okay? But still we have sent the MENCA to the Mars. And this is how the whole spacecraft is loaded with payloads, pay and load. MENCA sitting right over here, and these are all cameras or imaging instruments looking towards the moon. So placement of various instruments on the spacecraft is a very essential aspect of depending upon what science you want to do. We got a lot of information about the full disk images because the highly elliptical orbit of the Mars orbiter mission, and it changes as per season because Mars has season very similar to the Earth. Mars is tilted by 25 degrees like Earth. So this is how it goes around the sun, but it has a much more elliptical orbit than the Earth, and therefore seasons are much more dramatic. We can use MCC to look at both clouds and dust in the atmosphere of Mars, or even the Phobos and Deimos, the two very small satellites of Mars, have been imaged because of the highly elliptical orbit of the MOM. And we could also see very clear cut signatures of valleys. You see over here, this is a part of the Mangla valleys, which very clearly suggests that some water or fluid has actually flown on Mars. Craters of different dimensions, and this is the one which is for the Pita crater, which is a part of a big valley or valleys called Valleys of Marianas, which is a big canyon, probably the biggest canyon in the solar system. And this is a fall which suggests that this is almost like 2.6 billion year old. So we can actually gauge and date and get the information about how old the structures can be. The Menka instrument on the Mars orbiter mission gave us information about the nighttime or evening time, I should say, exosphere of Mars, telling that CO2 dominant atmosphere, which is the dominant gas on Mars, actually converts it to O by photodissociation of CO2, and O dominates in the upper region somewhere around 260 to 270 kilometers above the surface. And this altitude of changeover from CO2 to O dominated atmosphere is about 40 kilometers higher than what happens in the noon time of the Mars. So this is a new information which has come out, which is now changing our understanding that there can be changes in the altitude of photochemistry, dynamics, and energetics on the Mars. Also, we discovered suprathermal argon. And what does it mean is that if you have higher temperature species or hot species in the exosphere where atoms and molecules don't collide, then you can have a faster escape. So that means the Mars is actually losing its atmosphere much faster than has been thought so far. And of course, we also did observations when MEVIN, the NASA mission, was on the morning side and MOM was on the evening side, and we used the two spacecraft data to understand the day and night asymmetries. We also use MOM to do sun. And this was a unique way when the Earth and the Mars are on the opposite side of the sun, and the radio waves propagating from the MOM mission is coming towards the Earth. You can actually explore the solar corona. So we use the mission not only for doing science on the Mars, but also understanding the solar corona. I will skip this. Let us move to the Chandrayaan-2 mission. Chandrayaan-2 mission, much more complex and complicated than Chandrayaan-1, essentially because it had a Vikram lander and a rover sitting inside. And we all know what happened on 7th of September 2019, early morning. It was close to 3 a.m. But the orbiter of the Chandrayaan-2 is still in orbit around the moon, still orbiting, providing us excellent quality of data using these 8 experiments on board. And the most important of which is OHRC, optical high resolution camera, which provides you a resolution of almost like 1 feet from 100 kilometers. This is the highest resolution camera currently operating around the moon. And this is the one which was actually used for deciding the landing site of the Chandrayaan-3 mission. Dr. Vikram Sarabhai has a crater in his name on the moon, which is called Sarabhai crater. And this crater is on the near side. So you can actually use a small telescope to see this crater because it's about 8 kilometers wide and 1.5 kilometers deep. We also have a dual frequency dual frequency SAR experiment, LNS band, which provides you information beneath the surface up to a depth of few meters, and you can actually see what is present in this beneath the surface vis-a-vis what you see as a crater in the optical. And this information is also very useful when we are deciding the landing site to know whether there are buried craters around the landing sites. The dual frequency radio science experiment, which was SPL was the PI of this instrument. And this has told that around the wake region of the moon, you can have plasma densities as high as 10 to 4 particles per cc, which is significantly large. And you have seen that our instrument on Chandrayaan-1, when we did this kind of radio occultation, it also told plasma densities of few 100 particles per cc. We also know now how the hydration of the moon is with respect to water distribution, argon distribution coming out from the CHASE instrument, and the elemental composition distribution coming out from XRF instrument called class on the Chandrayaan-2. These are just glimpses of the science which is coming out from the Chandrayaan-2 orbiter itself. And very recently, this chase has been used to understand what happens when CME comes and hits the moon. And we could very clearly show the signature of enhancement in the total pressure, essentially enhancement in densities around the moon because of the impact of CME which comes, because you see this enhancement exactly happening or coinciding when the CME which happened in May of 2024 coming and hitting the moon. The XSM instrument called on the Chandrayaan-2 is essentially looking at the X-rays coming out from the sun and hitting the lunar surface, which produces X-ray fluorescence, which is seen by class instruments. So this is used as amount of flux which is falling on the lunar surface, but it has also given us a lot of solar science or science about the sun, because this is the best solar X-ray spectrometer currently operating in 1 to 15 kV range, and it provides you a spectrum which you see over here every 1 second. And it is such a large dynamic range that you can see sub-A class flares to X class flares using this instrument. And that's why this is now being used by many scientists world over, and more than 20 scientific publications come out from this. Half of them are from people who are not connected directly with this XSMT. And you can see the solar activity, which is plotted over here, right from September 2019, when the Chandrayaan-2 was inserted into orbit, to July of 2025. And which also shows how solar activity is changing. Now let me come to the Chandrayaan-3 mission, which has the Vikram lander and of course the rover which is sitting inside. But since the Chandrayaan-2 orbiter is already in orbit around the moon, we said we don't need an orbiter, we only need a module which takes the Chandrayaan-3 lander. And that's why we call this as a propulsion module. There are experiments on the lander and the rover. We have 3 experiments: ELSA, which looks at seismicity; 𝗂𝗲, which is developed in SPL and PRL together, looking at the properties beneath the surface; Langmuir probe, developed in SPL to look at plasma properties; and of course we have a NASA reflector. On the rover, we had 2 instruments: APXS, which is alpha particle X-ray instrument, developed in PRL, and LIPS, which is laser-induced breakdown spectroscopy instrument, developed in LEOS in Bangalore. And I will give you some science which has come out from these instruments. And they have provided us a lot of new information about and around the landing site. So this is how the spacecraft lander is sitting on the propulsion module over here. And inside that is the Pragyan rover. This is the landings, our launch site, 𝗗𝗲_𝗂𝗲, which is a spaceport of India, and GSLV Mark III. The Chandrayaan is sitting right in the top of this side. You can see over here. Oops, you can't see this on this side. And we had the launch in July of 2023. You would like to see the launch? Huh? Let me see whether it plays here. I think it's not catching the sound, or it's not playing. Sound card is there. I think it's not showing up. It's not showing up the movie. Nice. Movie also is not playing, right? It's playing? It's playing, but sound is not coming. Is it? You have a sound card? No? It's not coming to HDMI. Generally through HDMI also it comes. Sound is on. Sound is on. You have that? It's playing, but no, but you. No, this sound will not come good. Actually, wait. We're talking about this one. It's on actually. It's 100%. very low.
We have a majestic liftoff of LV-3M4 rocket carrying India's
Generally, HDMI carries sound automatically.
प्रज्वलन और सफलतापूर्व उत्थापन LV-3M4 रॉकेट का यह भीमकाय रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है, जिसे हम यहाँ महसूस कर सकते हैं, और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। LV-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान 3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving closer to the accomplishment of the most important milestone.
There's some disturbance also. Anyways, so we had a fantastic launch and we went into orbit around the Earth, then we went into lunar transfer trajectory, went into elliptical orbit around the moon, and then went into 100 kilometer circular polar orbit, and then came down to 100 by 30, and then only we started the landing. And we had the D-Day. All of you must have also witnessed that evening of 23rd of August 2023. And let me relive that moment of the last part, about a minute of it.
Sensors that are updating at this point are providing confirmation of the safety of the landing site.
As expected, the retargeting is going on, and this is a very good
I don't know whether the
signature
sound is
for
coming.
the lander.
It's coming? Okay.
अभी आप ये देख सकते हैं कि
So
लैंडर
this
की
is
ऊंचाई
just
लगभग
something like
65
50
मीटर
meters
के
above the
आसपास बची
surface.
हुई है।
We have started from 30 kilometers, and we were almost like this when we started landing, and then slowly as we coming down,
Currently,
we are
only
becoming
2
slowly
engines
vertical.
are
So now you are seeing
being
almost the
fired,
vertical part,
and we
where
are nearly
we are
at
doing retargeting
zero
also,
velocity,
because this is all
vertical
autonomous
and
landing.
horizontal.
There is no command and control which can be given from the ground
approaching the
to
moon's
do anything
surface.
on the spacecraft. It is completely autonomous. It has to decide of its own,
लैंडर
using
की
its own navigation
देखभाल को
system,
कम किया
guidance
जा
system,
रहा है,
the
और
sensors
हम
which is
अब
providing us
50 मीटर से भी
data online
कम
on
आ
board,
चुके हैं।
and it is calculating and deciding the landing site. So it does the retargeting and then finally decided that yes, this is the best place for me to
Shri
land.
Narendra Modi ji, who is here to
So we are
encourage
almost like
us,
20 meters
and
above,
he is
and very soon
critically
you will
looking
see
at the
it has
visuals.
landed. Prime Minister was there around in South Africa that day, so he was watching us live from there.
जी हाँ,
And we have
आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
so we had the fantastic touchdown,
People are applauding.
and this
Let
made
us
India the
all
fourth
wait to
country in the
hear
world to
from
have
the
the soft
Secretary
landing
Department of Space and
on the
Chairman
lunar
ISRO.
surface, but the first
Shri
country to
ESSO-NCESS.
land in the polar regions. Okay, so after this, everybody was over the moon. I was also over the moon, so I took this selfie for myself. But then our job is not over. We also started listening to what's happening around the world, and let me see whether this can play.
India has done it. It has become now the fourth country to land a spacecraft on the moon after the US and China and the former Soviet Union. Just moments ago, we're talking just a
India has made space history, becoming the first nation to soft land a spacecraft on the moon's south pole. India has become the first nation to successfully land a spacecraft near the south pole of the moon. The country's PM Narendra Modi has praised the achievement, saying that mission success belongs to all of humanity.
Spacecraft Chandrayaan-3 is attempting to become the first to land on the
The whole
moon's
world was actually
south pole.
celebrating this
India
success.
is the first country in the world to land a spacecraft near the moon's south pole, a moment of history for the country. It was a tense final 6 minutes as it descended onto the lunar surface. Let's show you the moment. First of all, let's take
The agency is celebrating the successful moon landing of its Chandrayaan-3 spacecraft.
Okay, now India's lunar probe Chandrayaan-3 has landed on the moon's south pole. India is the first country to touch down on this part of the moon, which is believed to hold pockets.
We begin with some historic news. India has become the first country in the world to successfully land a craft near the moon's south pole. Prime Minister Narendra Modi was watching the mission from South Africa and congratulated
Okay,
the team
so
back home.
let me move forward. So our job now in the mission control was to bring out the rover which is sitting inside, because we had to do science. we have done this many times in the lab, but now this is happening on the moon surface, right? You have to command the spacecraft to release the ramp and then actually the rover out. So how the ramp deployment happened? Just a small glimpse, because this was a very, very crucial moment. If the ramp does not deploy, rover will not come out, right? And therefore we are all anxiously waiting for this moment. We saw ramp deployment happening. These were live pictures which was coming in the control room, and we could see the Pragyan rover for the first time. Then we put on the solar panel. We'll see very soon. And now this will get charged, because rover is working on the solar panels batteries, and therefore the rover has to be completely charged before it rolls down. After this happened, we waited for several hours for batteries to be charged, and then we actually started rolling down the rover. This was also a very important moment, because rover is hauled on the ramp. Now you have to release it to start rolling down. You see how it is rolling down on the surface, and you can see on the other side the shadow which is coming out. And this is the first touchdown. You can see the Indian emblem and the flag on this. And at this point I was a little scared, because I could see the crater right in the front. And I was a bit worried myself when you are seeing it live there, that Baba, you should not cross this first time. Because this is the first crater we are seeing. We have not even seen how a rover is working on the surface of the moon. But luckily, after looking at the data which came out from those two cameras in the front, we found that it can navigate, and that's how it was able to navigate its first crater on the lunar surface. But then we found another big crater right in the front. And he said, bhai, abhi nahi hoga. We can't go through this one. We have to come back. And therefore you see here the returning back of the rovers, the wheels of the rover making prints on the lunar surface. We could also capture our lander from the rover. So this is a selfie, you know. Chota bhai Pragyan. I use Hindi in between, samajh mein aa raha hai? And the bada bhai Vikram sitting. So Chota bhai Pragyan said, I will take selfie of you. You have taken selfies of me rolling down. I will take you. And this has become an iconic picture which also shows how our instruments have been deployed, and I will talk a little bit about that. But as the rover started moving away from the lander, we took many pictures of the rover looking back, and also sees what is there around the landing site, and you can see these boulders which were also there present. So this is how the deployment of the 𝗓𝗲 instrument, you see beneath the lunar surface up to a depth of almost 10 centimeters. This was deployed. The 𝗓𝗲, the seismometer, which was also deployed on the lunar surface, and the Ramba LP, which is sitting over here on the top deck of the lander. You see the shadow of this actually on this. And these are all taken, this was taken by rover, and this is taken by the lander itself, which clearly suggests that all the instruments have been completely deployed. And we all know that 23rd August is now celebrated as National Space Day all over India, and I heard here also it was celebrated very well. So we landed at a point which is now called 𝗓𝗲, and this is where the Vikram lander is. We started moving into this direction towards this big crater. We found no, we can't navigate. We came back, started moving in this east direction, then we found no. Our geologist in the mission control said no, we should go into this side, west side, where we are seeing more fresh craters, and therefore we started moving to this west side, and then we navigated very close to this place, and then very close to this crater, and then finally the Pragyan rover is still sitting on the lunar surface at this location. This whole distance covered is about 103 meters over a period of about 10 days. The instruments worked very well, and a lot of science data has come out. This is a nutshell of this, but I will tell you a little bit more about each of them. The 𝗓𝗲 instrument was capturing the signals of rover movement on the lunar surface, but it also captured several other seismic activities which is happening, which we called as uncorrelated event to any activity happening on the lander or on the rover. And you can see the signatures over here. These are the rover navigation signatures, but these are the ones which have been captured by 𝗓𝗲, and which correctly suggests that you can have this kind of seismometers present on the lunar surface to understand the seismicity of the lunar surface. The Langer probe, which is sitting on the top deck, as I just tell you over here. And this was a time when the moon was actually passing through the Earth's mantle tail. And we see the densities of order of about few hundred particles per cc, but fluctuating or varying. And you remember that on Chandrayaan 1 observation also we had seen few hundreds of particles per cc densities. That means we have densities right from very close to the surface to almost like few tens of kilometers above the surface, densities of the order of few hundreds of particles to few thousands of particles per cc, which is a revealing information for us, both combining Chandrayaan 2 and Chandrayaan 3 data. The 𝗓𝗲 instrument, which was developed by PRL and SPL together, we have PI of 𝗓𝗲 sitting over here, Nizi is here, and you see this 𝗓𝗲 was actually mounted like this up on the lander, and then it was deployed like this, and then it went inside the lunar surface. So there is a lot of mechanism which was involved of putting this fellow down first after landing, and then drilling it, or not drilling I should say, what you call, moving it down into the lunar surface up to a depth of 10 centimeters. This is the first observation of its kind then. No such observation exists on the lunar surface. What it has seen is the distribution of temperatures using these 3 sensors, 10 sensors, which is sitting over here very close, around in length of about 10 centimeters. And it also has a heater which is sitting over here. So these are the temperatures which this thermistors have measured, and you see how the temperature varies beneath the surface, very close to the surface to beneath the surface. This is the local time. This is actually in local time on moon, because moon day is 14 Earth a day. So we landed almost like almost like 7 or 7:38 a.m. morning at the landing site, because we need sunlight for the lander's batteries to be charged by the solar panels, and of course also the rover. And you see here, from after the all deployment happened, we have observations very close to 10 to almost like 3 p.m. local time on the moon. And if you look at the temperature difference from the top to bottom, it is more than 50 Kelvin. So that means in the top 10 centimeter itself you have very large temperature gradient. That shows that the conductivity is very low, which we also tested using this heater putting on and collecting this data for almost like several hours, and then calculating back the thermal conductivity, which you see over here, is extremely low. That means that regolith can actually be used as a thermal blanket. Of course it was known, but now we also know much better that yes, it is absolutely low, and this can be actually used as a thermal blanket. So when you are putting habitat on the moon, you can use this regolith for this kind of activities. We also came to know that this site where we have landed has slightly higher temperature than what was expected, because on the lander legs also we have thermistors or temperature measurements, which suggest the temperature to be almost like 10 to 15 Kelvin lower. And we found that why it is so, we found that small topological changes on the lunar surface of few degrees can change the temperatures or change the values around the locations, which is of the order of few meters. That means over a few meters you can have changes or gradients on the lunar surface, essentially because the moon is not conducting heat. So you can have localized heating and localized cooling regions, and therefore we suggested that beneath the surface of about few tens of centimeters you can even have water ice present at 70 degrees south rather than going towards the polar regions. The APXS instrument I am just showing over here, it was sitting right in the front plate, and you will see this plate moving down in one of these movies, which shows that every time when we are making measurements, this plate used to come down, collect the data for several hours. You will see white plate moving down. This is again rover seen by the lander, and we collect the data for several hours, and then plate will move back, and then the rover will move. So we conducted this experiment almost like 30 times wherever the rover was stopping. So these are the locations where we got the data from APXS, and using this we could detect both major and minor elements, right from sodium, magnesium, aluminum, silicon, sulfur, potassium, calcium, titanium, chromium, manganese, iron, nickel, and even zinc. We also found that this region around the landing site is almost uniform, but we found higher abundances of magnesium. And this was actually a dilemma for us to say why we are seeing higher abundances of magnesium compared to, because this is believed to be highland region based on our understanding about the moon. And we said this is only possible if we have material coming out from the lower crust of upper mantle coming into this region, because as the moon gets differentiated, you will have heavier elements moving toward the core, and this region from the lower part of the moon should have come here, and which would have brought higher amount of magnesium. This hypothesis was given in a paper in Nature. Of course, it was published in Nature, but then this was actually corroborated when we look at the volatiles, particularly the sodium, potassium, and sulfur. And we found that we have higher abundances of sulfur and lower abundance of sodium and potassium at this landing site. So the hypothesis which was given in Nature was again validated by looking at the volatiles around the landing site. This is again APXS measurements, which suggests that it is only possible if you have some material coming out from SPA. And if you look at this picture over here, this is the southward, this is the landing site of Chandrayaan-3, and actually the landing site is about 300 km from this South Pole Earthquake basins. South Pole Earthquake basin is about 1000 km diameter. So if a huge impact has happened, material would have been thrown out. And therefore, this Chandrayaan-3 landing site should also have received material from the SPA or lower part of the moon, which in turn means that upper mantle region must have come on this landing site to make sulfur abundance also anomalously high in addition to the magnesium. And that's why we gave this kind of cartoon, which again got published in Nature Communication, talking about we are seeing primitive material at the landing site. We also look at this landing site in much more detail, telling that this is a landing site which is quite old actually, going down to older than South Pole Earthquake Basin, or even something like 3.7 giga-years and more. Actually, this all is coming from the Chandrayaan-3 observations, combining with the Chandrayaan-2 observation to understand the landing site. And then we have started also looking at what could be the best possible ways to explain that. And one of the papers suggests that this would have been a big crater here actually, which has now been dotted by another smaller craters. That means this landing site is really pretty old actually. Now what next? Another 5 minutes? Okay. So now we are working on the Chandrayaan-4 mission. Chandrayaan-4 mission is essentially a highly complex mission where we are interested to bring material back from the moon. So far we have orbited, we have landed, right? But now not only we have to land, but we have to collect the material and bring it back to the Earth. And therefore, the mission capabilities has to be expanded like anything, which includes the propulsion module, that is the module which will take the lander into the orbit of the moon, deorbit, go to the surface. A part of it will come out which is called ascender module. It will dock with the another module which is in orbit around the moon. This will come together into the Earth or near the Earth, and then a small part of the module will re-enter and come to the Earth. So this is a complex mission which involves a lot of docking, combining two spacecraft or separating two spacecraft. And that's why this is a highly challenging, but you must have heard about SpaceX, which is a docking experiment which is very recently done in the beginning of this year, where we have demonstrated that in space itself we can combine two spacecraft and then undock them, and then combine and undock. And this is a very complex technologies because nobody gives you have to generate of its own, and it's also very complex because it has to be done perfectly well. And therefore we are going to do a SpaceX 2 experiment also very soon, where we are going to rehearse this kind of activities which has to take place not around the Earth now, around the moon. So this is a very complex mission with several modules which is written over here, and we will also be needing probably 2 launch vehicles, because the modules has to be docked in the space, go to the moon, undock, go to the surface, collect the data or samples, and then come back. So part of it will be sitting on the surface, part of it will come back into the orbit. And therefore, we are interested to have this kind of experiments to be done in future, which is the Chandrayaan-4 mission. And we are also working on another mission, which is called Chandrayaan-5 or 𝗨𝗲 mission, where our idea is actually to go to the perfectly polar regions of the moon to look at permanently shadowed regions. If you look at this picture over here, the dark black, this is actually a crater, right very close to the pole, 89.44, that means south. Now these regions are permanently shadowed because they never see the sunlight. Because moon is going almost like vertical, 1.5 degree tilt around the earth. So if you have craters in the polar regions, they will never see the sunlight. And therefore the temperature goes down to almost like 30, 40, 50 Kelvin. So if you have any volatiles sitting there, they will be sitting there for ages. Nobody is there to disturb them because no sunlight, no photons are reaching there actually. And our idea is to go inside these regions to see what is there. Nobody has done that. And therefore this mission called 𝗨𝗲, which is the ESSO-𝗗𝗲 or India-Japan collaborative mission, where India is providing the lander, Japan is providing the launcher and the rover, and there will be instruments on the rover which will be developed both by India and Japan. But it is also very challenging because the lander has to be charged and the rover has to be charged by sunlight. That means the lander has to sit at a region where you get the sunlight for continuously 6 months at least, because mission lifetime is about 3 to 4 months. Now at the polar regions, there are certain regions where the sunlight comes almost like 9 months. So you have to land at a strip, like a landing plane at that location so that you see the sunlight continuously. The rover which will come out will get charged by the sunlight, go into these permanently shadowed regions, explore, come back and get charged and go to the next one. So the mission lifetime is about 3 months for this, but this is also very, very challenging because the landing has to be very perfect. And the idea is to look at these regions to know what kind of volatiles is there, including the amount of water, because water is of course very, very important element, and for any habitat to be present there for a longer period of time, we need to know whether the water exists and where the water exists. In addition to this, of course, we are talking about the Venus orbiter mission and the Mars lander. The Mars lander, because we already had an orbiter mission in 2013 and it worked after reaching the moon, after reaching the Mars in 2014 for almost like 8 years. But now our idea is not to send any orbiter further, we should actually land. But land not with the lander, land with the rover straight away so that you start moving around. And therefore this mission is also called Mars rover and relay orbiter. So once you land, you need a communication mechanism because Mars is also having a rotation period very similar to that of the Earth. So some of the times this landing site will be on the far side or the night side as seen from the Earth. And therefore you need an orbiter around the Mars orbit for doing the communication with the Earth. And therefore there will be a relay orbiter and Mars rover mission. Venus is a very, very strange planet. Venus is dominated by CO2 like Mars. Venus has a surface temperature almost 90 bar. Surface pressure at the Earth is 1 bar, right? So almost like 100 times. Surface temperature about 800 Kelvin. So surface is very, very hostile. But as you go up into the atmosphere, almost an height of almost 50 kilometers. So the temperatures comes to almost like that of Earth as well as the pressure. But then there comes that it is full of clouds. Clouds of sulfuric acid. And therefore, this picture which you are seeing here is of the clouds only. You can't see the surface of Venus. And it rotates very slowly. Its spin takes about 243 Earth a day to spin on its axis. So that means you have very long day and very long nights. If somebody goes there, 120 days sleep, and 120 days work, right? So the life is pretty challenging, but of course it is also challenging to see why Venus is such a different planet compared to Mars or Earth. And now you see Mars dominated by CO2, Venus dominated by CO2, and you have Earth in the bit in between of them, dominated by nitrogen and oxygen. So what happened to Earth so uniquely that it has an atmosphere of nitrogen and about 20% oxygen compared to these two planets which are dominated by carbon dioxide. So it is important to do interplanetary, or I should say comparative planetology, to understand the evolution of the planet Earth also. It helps to understand the planet Earth also very well. And therefore we are planning to have this mission to Venus. This will be an orbiter mission which is going to make us understand about various processes which is happening in the atmosphere, the clouds, the aerosols, the trace gases and the dominant gases, and of course the interaction with the sun and the solar wind. In the future we are also talking about not just going to Mars and Venus, but also establishing the Bharatiya Antariksh Station. And this is going to be next step after our astronaut or Gaganyatri 𝗗𝗵𝗂𝗃𝗃 has returned back from ISS very safely. That we are having the Gaganyaan program where we are planning to have the Indian astronauts going to space and utilizing this as the base. It is not that we have to send the spacecraft into space and orbit and come back, but it is leading to establishing the ISS, or not ISS, actually I should say BAS, Bharatiya Antariksh Station. And this is a part of our exploration towards the moon also, because our plan is to land humans onto the moon by 2040. But for that to happen, you have several other missions which is in pipeline to the moon, including Chandrayaan 6, Chandrayaan 7, Chandrayaan 8, and then exactly the same spacecraft which has to take humans to moon should go to the moon and come back safely to demonstrate that everything works fine. So it's a long-term program of several decades where the plan is to not only do exploration of the moon, but also lead to human landing on the moon or Indian landing on the moon by 2040. And once we are able to achieve that, probably we are talking about making moon as a base of doing future exploration and further exploration, because moon has 1/6 of the gravity. So landing from Earth is much more difficult, or sorry, launching from Earth is much more difficult because you have to spend 6 times the fuel or the energy. But launching from moon will be much easier. So if you are able to utilize the resources which is present there on the moon, you can actually do future exploration, making moon as the base. So the future is very bright. There is a very long drawn program for future exploration, and we need people, young blood, to be inducted into these kind of programs. And therefore I urge many of you who are young scientists sitting over here to get involved into this kind of programs, because this is the one which is going to lead India to very greater heights. Not only that, but also to explore various planets in the solar system, not just the moon, but also Mars, comets, asteroids, and of course understanding that how we can make Earth as a better place to live. Thank you very much. Yeah, we can have the lights now. Sorry.
Water or ice?
Chandrayaan 4 is essentially for landing, collecting the sample and bringing it back. Chandrayaan 3 we have sent sensors, right? Both on the rover and the lander. But the issue comes is that you can't build a big instrument and send it. And the masses of this is something like few kgs, the sensors which have gone there, the instruments which have gone there. So our idea is to bring the sample back into the lab and do the thorough analysis, rather than doing the analysis and sending the data back to the Earth. But we are still talking about putting a instrument on the lander, because when you have to collect, you have to do some kind of drilling, to bring back the sample. And during that, if you are able to sense what kind of gases or volatiles, not gases, volatiles, which is present there. So that kind of sensors are getting developed, and probably that is the only kind of sensor which will be flying. But our focus is not to do any science on the moon, on the lander right now. Our focus is how to bring back. Because when we are talking about this huge mission also, we are talking about hardly few kg of sample coming back. You can imagine the kind of, the resources which is required for doing this kind of missions. But it is going to be a technologically revolution for all of us.
There were, certain signatures of channels.
On?
Channels on the surface geomorphologically. I mean, there were
on the
some
Mars.
valleys.
Mars.
What could be the reason?
That clearly shows that fluid has flown in the past on the Mars. And there are a lot of indications now coming from various other instruments which have been flown on, are currently working, that yes, water would have existed on Mars. And that's why we now say that Mars was hot and wet in the past. Now it is cold and dry. There's a large change even in the surface pressure of the Mars. And I was talking about the escape of Martian atmosphere, right? So that means that Mars would have a good atmosphere in the past, but it has lost and it is losing also currently. Sorry?
The craters.
Craters, huh?
It is due to the impact of meteorites? Or
Yeah, because moon doesn't have an atmosphere. Any body which is coming will hit and produce a crater. And that's why you will see craters inside that, another craters, on the walls of the crater will be craters. So anywhere you see on the moon, it is full of crater. Crater inside crater, crater outside. Crater ke andar crater, crater ke bahar crater. Idhar crater, udhar crater. Everywhere crater hi crater.
Is there a way to know the depth of the crater from your?
Yes. So we have dam, because TMC has 3, So you can actually generate the dam, digital elevation maps of these craters actually. The 𝗂𝗏 crater which I showed has told us the depth is about the depth is about 1.5 kilometer and the width is about 8 kilometer. Right. So once you generate dam, you know.
I think it's a very layman's question. That whatever instrument you use and the material you use for the instruments, all are indigenous?
Largely.
Because basically asking the question, the relation with the US and India. Which is
all the instruments, I should say, were developed in India, in different labs, including PRL, SPL, URSC, LEOS, and things like that. So these are instruments which are developed in our own labs.
And the materials are also available from India. Okay, thank you.
Yes. You can use the mic so that others can hear you.
Yes, sir. Thank you for the nice talk. My question is, in one of your slides, you have mentioned that the landing site, the dating is 3.7 GA. So it was done by, in which method?
This is a method called crater counting. So what you actually have to do is, you should have a good image of the landing sites and look at the amount of craters present there. And there is a kind of formulation which suggests how the number of craters leads to the age of the site where you are calculating this. So more number of craters means the site is old, because you will see craters demolished by craters. As I was telling, crater ke andar crater, crater ke bahar crater. So you will see a crater, and then you will see hundreds of other craters sitting inside that crater. So if you do this kind of analysis, you will know how old this site is actually. So there is no physical way of doing this. This is actually an empirical way of doing this. And it is found to be quite true, because based on the observations over the last 4 or 5 decades, we know that.
So it was done by the lander?
Not lander, by the orbiter. Because we have a Chandrayaan 2 orbiter, right? And Chandrayaan 2 orbiter is still working. So it's providing us continuously data. So we are now corroborating that with the landing site data.
And sir, one more question. And you have that elemental composition you have mentioned, that was done by rover.
Right.
So means how much distance it traveled within?
I just mentioned that it traveled 103 meters as it crisscrosses, but if you took at the radius, it is almost like 60 meters kind of thing. 50-60 meters kind of thing.
So around that area, that composition was home.
Right.
Thank you, sir.
Does it mean any possibility that it will wake up, or I mean, because that was
why you want to wake that fellow? It is sleeping comfortably. See, it was not meant. This mission was only for one lunar day. Right in the beginning itself we are knowing. So everything was planned accordingly. And as I just mentioned that we landed almost like second day, or you can say around 7 a.m. or 7:30 a.m. local time there, so that there is sufficient sunlight, right? And so that the batteries can be charged by the solar panels on the land and the rover. But we were not expecting that it will last beyond 14 days. Essentially, when the sunlight goes away, the temperature goes drastically down there. Temperatures can be 50 to 100 kelvins, right? It is something like 200 degree Kelvin below the normal temperatures, right? So it is difficult for any electronics to survive at that ultra cold temperatures, unless until you have heating mechanism. And we did not had anything, right? So that's why the plan was to survive for 14 days. We only thought that yes, in case it survives, let us see. That's all. And that's why in the future, the plan is that if you are going to live for a longer period of time, you have to face the ultra cold temperatures on the night side, because night side can be 50 or 100 Kelvin. Day side has to be 400 Kelvin. So you see the temperature contrast on the moon, right? So you need to have a mechanism for heating yourself. There are two possible ways. One is meteorites coming and hitting, and second one is moonquakes, because moon is also believed to be having quakes, not unlike Earth, because tectonic activity is not very strong as in the case of Earth, but still there are quakes which can be generated by thermal gradient. I just mentioned 100 and 400. If you put 300 degree temperature change, right? So this is one aspect. Second is this meteorite impacts. So they will actually keep on changing the topology, topography, morphology of the lunar surface. And to just supplement to what you are asking, it is believed that over 50 million years, the top portion of the moon churns, because constant bombardment is happening, right? And it will throw out the material back, it will scatter around, another fellow will come and scatter around. So you are actually changing the regolith continuously. Atmosphere तो नहीं है भाई. There is no atmosphere on the moon, but what we know now is that there is a tenuous atmosphere which we call as exosphere. Exosphere means atom and molecule don't collide with each other, right? That means the main free path is much larger than the scale height. So the fellows will not collide. They are independent fellows sitting there and moving around, and some of them have enough energy, they will escape. Okay. Currently we know that yes, there are gases, because our chase instrument on the Chandrayaan 1 mission, which was there on MIP, has given us indication, which I just showed you. There were also a impact in the polar regions by 𝗗𝗁𝗁 mission of NASA, and they have a spent rocket which was actually impacting on the lunar surface in the polar regions. The material which was ejected out was mapped by the LRO, which was flying at 100 kilometers. And they have seen many molecules present there. But they are not in the atmosphere, they are sitting. So somebody has to give them some energy to come out, right? And that was done by the Alcons. 𝗂𝗲 instrument, which is there still in orbit around the moon, is also providing a lot of information about various volatiles, including, of course, the distribution of argon, neon, helium, and things like that. We are seeing signatures of many other gases, but we are still working on them to confirm because we are seeing at 100 kilometers circular. We know that many of this species condenses because temperature falls down, right? So from 400, if you put 100, there will be condensation always, right? So atmosphere condenses. So those species which are not a condensing, non-condensing gases, they will be having a higher densities in the night side compared to day side. Planetary, I see. Okay. CSR and GRA. Acha, oh, okay. Moon. Mars. Okay. So surface of Mars. Yeah, I can understand. Yeah, I know. Good. Lot of data is there on Mars also from our instruments on the Mars orbiter mission. And
large volcanoes had any effect on the present day climate of Mars? Did the climate, as you told, the warm and wet climate change the current dry? Was that volcanoes one of the primary reason for that? I was interested in knowing that one.
it could be in the past, because the activity is much higher in Mars in the past compared to now. Only now what we see is this dust levels, which is very frequently happening on the surface, but it's very localized phenomenon. And then dust storms. This is like a global phenomenon which can cover almost like half of the Mars at times. Other than that, right now we have not got much evidence about volcanic activities to a large extent, but we have observations which suggest the increase in SO2, right? Which means that volcanic activities are happening.
Yes, sir. Actually, sir, the inside data also detected multiple Mars-quake-like events, like volcanic-like events in Mars. Actually, they are telling that there might be magma movements in the lower crust region, but still more observations are required regarding this.
So evidence is coming from the field also. It has come from Venus, Mars Express, as well as. But we are not witnessing any huge volcanoes because there are so many cameras.
Sir, that's another suggestion, sir. If you are planning a landing mission, like why can't we like target 𝗏𝗏 or something like that? Because yes, sir, that's what I was. No, sir. According to no, sir. I see that most geological events are mainly focused in 𝗏𝗏 and LCM. So, if you are
It all depends upon what is your interest. So your interest is something different. You can actually see who is developing instrument. We are looking. Yes.
In the place of rover, why we not using that some small drones? Because that is lighter as well as they can be movable at some distance and go and take away the data. Because the problem with rover is the craters, but with the drone, that problem will be solved. Yes, yes, sir.
See, you have to go land on some other planet, and then you have to think how do you fly a drone. We are talking about a problem.
Yes.
Mars it is possible to do because you have an atmosphere.
Yes.
The moon you can't do because there is no atmosphere.
Thank you, sir.
So we are working on it. So it's a technological development. It has to be proving before you.
Thank you, sir.
Thank you, sir, for such an insightful and interactive lecture about moon exploration and briefing Chandrayaan-3 mission as well as upcoming Chandrayaan-4 and LUPEX mission also, and even future interplanetary mission. And especially thanks for showing us how much each mission is advancing from the previous one, as well as for portraying that how vividly that Indian planetary research is advancing nowadays. Thank you very much, sir. As a token of our gratitude and respect, now I request our director, sir, to kindly present a memento to our chief guest. Now it's time to give the memento to M. Baba, sir. So please come. And now, thank you. Thank you, sir. To conclude this memorial program, I now invite Dr. 𝗓𝗲 to deliver the vote of thanks.
Good afternoon, all. Before I go ahead with the vote of thanks, I have a very exciting news to share to you all. Our director was today awarded the prestigious 𝗂𝗶𝗺𝗲 grant from ANRF, the National Association. So, on behalf of NCESS family, let us take this opportunity to congratulate director for this tremendous achievement and wish you many more success in the future, sir. And I'll come back to my duty. So it's a great pleasure to have Professor Anil Bhardwaj, Director PRL Ahmedabad, who has kindly accepted an invitation to visit NCESS and also deliver a talk during the 14th Professor Karunakaran Memorial Lecture. And Professor's talk provided insights on ISRO's planetary mission, what has been done in the past, what is being happening now, and what are the future missions that are planned. Indeed, every Indian is proud of ISRO's and India's achievement in the planetary exploration. And on behalf of Director ANSYS and ANSYS family, I thank you once again, sir, for kindly visiting here, ANSYS, and giving us this opportunity. Next, I would like to thank our former director, Dr. Pamba, who has always been with us for several of the events, and he has kindly accepted our invitation and shared memories of Professor Karunakaran with us. Thank you, sir. And I also express my heartfelt gratitude to our former colleagues, like say Dr. 𝗧𝗶𝗺𝗲 sir, 𝗓𝗏𝗵𝗂 sir, 𝗓𝗏 sir, and then scientists from VSSC and also some of our neighboring institutes. I thank you all for accepting our invitations and coming over here to be a part of this memorable occasion. Thank you. Then I thank our Director Professor 𝗗𝗶𝗺𝗲, our senior scientist, project staff, students, administrative staff, my own friends and colleagues for being a part of this event and making it a grand success. I also thank IT Wing for their support, the canteen staff, housekeeping staff, security staff, who all provided support for this successful event. And I also thank my students and who are here working hard to shift the stage from the sports day to memorial event. So it was very supportive from there to take it. Yes. I also thank the participants who joined in this event online. Thank you all. And I also thank my fellow Earth Forum committee members, Dr. Ramesh, Dr. Arka Roy, Dr. Sneha, Dr. Rudra, and 𝗓𝗏𝗺𝗲, for their unwavering support behind the scene. So once again, I thank you all. And join us for the lunch at 12:30 in our canteen. Thank you. With a national anthem.